and put that back up. We are starting chapter 15. Our test will be on Wednesday as a reminder. Same bat time, same bat place. I'll be there early. At least by 7, if not earlier. And if you take it in the AAC, just be sure to let them know. I need, oh shit, note to self. Send it over to them. Send test to AAC. All right, made a quick note so that I don't forget. But we're going to start 15. We put off the test for people that were taking tests on Friday and you didn't have as much time to study for the test on 14. So chapter 15 is on like divergence, curl, and gradients. We've covered gradients before, but now we're seeing how gradients connect to potential functions. And these are the formulas for divergence and curl. It's handy to remember them if you struggle with remembering. Divergence or div and dot product both start with D. Curl and cross product both start with C.
Actually pretty convenient.
So easy way to remember it. So let's just go through these. I did hit record, right? Yeah, I did. Okay. All right, so for A, we've got the divergence of F. If you forget, the del operator or nabla is ddx, ddy, ddz as a vector. And I've got xz cubed, 2x squared y to the 4th, and 5yz squared. I guess I could have wrote that with a little bit better on the room.
X. Oh, wait, what? X third.
So when we do ddx, so this is.
Oh gosh.
What is these?
Well, let's see how.
That.
All right. Crisis averted.
Crisis averted indeed.
So I'm deliberately writing it out a little longer than I would if I were to solve this, because I'm comfortable just applying it. But I want to make sure y'all, as a reminder of how the dot product works, because some people try to give me vectors and stuff. It does not produce a vector. It produces a scalar. A scalar is something that is just a value, not a vector. And so I get z cubed for the first part. Here I get 8x squared y cubed. And on z, I get plus 10yz. So that's the divergence of F. You will see it written like div F or the actual operation it does. They both mean the same thing.
Dumb.
Yeah, this time was 0.
All right, let's take a look at the curl of F. Curl of F is the cross product of the del operator and F. So I think it might be easier to write out F first along the bottom. I've got xz cubed. I've got 2x squared y to the 4th. And I've got 5yz squared. Now I'll put in my other stuff. All right, so I have an I component of the partial derivative of 5yz squared with respect to y is 5z squared. Then I'm going to subtract ddz of 2x squared y to the fourth, which is 0. Then I've got minus j hat, because the second part is always negative. I've got 5yz squared, the derivative with respect to x is 0. And then I'm going to do some minus the partial derivative with respect to z of xz cubed is 3xz squared. And I've got a k hat. In k hat, we're doing the partial derivative with respect to x of 2x squared y to the fourth, which looks like 4x y to the fourth. Minus the derivative with respect to y of xz cubed is 0. So 5z squared, the two negatives make this positive 3xz squared, and 4x y to the fourth. Curls produce vectors. So curl of f or the cross product of del with f is the same thing. That looks funny. I'm going to rewrite that. Divergence produces scalars, and and curls produce vectors. You guys ready for the next set? Let me copy over B onto this form real quick. I didn't think I was going to use as much room as I did.
So, you know, the xc squared or xc cubed is the function. So yes, what is like dy dx or y?
Did I miss something? You guys ready for number B? Number B, that's what I said, exactly that, number B. Because I know that B is a number. All right, B.
Let me chat.
So we want to do the same thing here. We want to do the divergence of F.
In case he comes. Well, you need to wear your spare base. Well, you have a spare one. That's why you have your face mask.
So I think for one another time, I'll continue to write out what this is. ddx of 7y cubed z squared plus ddy of negative 8x squared z to the fifth plus ddz of negative 3x y to the fourth.
Just 1 second, I can see in board.
So it looks like I get 0 plus 0 plus 0, right?
Yep.
So what does this mean in terms of F is a vector field?
0.
And at every point in it, irregardless of x, y, and z, the divergence is 0, which means there is no flow or movement anywhere in the vector field.
That means we don't need.
I'm sorry, not no flow, but no net flow. Let me rephrase that. The net flow at every point is 0.
So that means that at any given point, the net flow is just going to be canceled out.
So it could be like this. We could have Jeff just going in one direction and leaving in the same direction at the same amount.
Right.
It could be going upward. And we could have a bunch going on. But as long as what is going into the point is the same as what's going out of the point, the divergence is going to be 0. If there is more coming out of a point, the length of the arrow is the magnitude, than is going into the point. Or equivalently of what I have right there, I could just have a little bit going in. And let's make one big vector going out.
We'll do an arrow.
Here, the divergence of F is greater than 0. There is more going out than in, so it is diverging from the point. Flow is diverging from the point. And if we have more going into a point, than is coming out, divergence is less than 0. It's a negative number. It's usually easiest for people to picture this with flowing water than anything else, because everyone has seen a river. Everyone has, presumably in this class, has used their kitchen sink, seen water flowing, like it hits the sink.
River, but I mean, I've seen on the internet.
Sometimes sometimes it's all going inward
I haven't seen a river in real life.
and nothing comes out. That's an actual sink. There's no
Unless you
nothing.
put like a big river.
Gravity works like this.
Why does that sound like a thread? Taking you out of the river.
I think that's that.
I honestly wish I went to that one part, the one like dead end, like
And you also have, for greater than 0, a fountain. A water fountain spits out water that flows all around it. So it's a source.
at the tank center. Other ones.
So that's like an idea of what divergence is doing.
Okay,
Let's do the curl for this problem. You guys ready for more? take a look at the curl. Let me rewrite the problem. Rewrite the vector field. And now we're going to take a look at the curl here.
Here's one.
So the curl of F,
Oh,
or the cross product of the del operator in F. What do we get? I think it's always easiest to put in the vector field first because it takes up the most horizontal space. Because if I were to start with ddx and ddy and ddz, I would not have spaced it out as much as I am doing these. And then my cross product matrix looks like shit.
so now I remember the teacher tier list.
From the vector field. So. It's like, at any given point, if you put in like, well, these have to-
So in the I component, I have negative 12 xy cubed minus a negative 40 x squared z to the fifth
This one is maybe it's more separate.
and j. Yeah, minus j. ddx of that is just negative 3y to the fifth.
It's just like the.
I feel like that. Why do you think that?
Well, it is. Yes, you have a question?
So you wrote, Z to the fifth.
Oh, you did it, you wrote z to the fifth instead of z to the fourth when you took the derivative.
Oh. No.
You're right, I did. Good catch.
Thank you for catching it.
Welcome back to reality. Oh, is this gonna be different? It's not
What
gonna
if
be
reality is just another dream?
Welcome back to reality. This is your reality.
What are we doing? ddx and then ddy.
And you wake up when you die.
We die, they die.
Because someone don't. You know.
What? No. Decision. Everyone needs.
I think maybe the best way to picture what the curl is, this doesn't clean up very well, does it? I mean, that will go to a plus, but other than that, nothing really cleans up really well. A dust devil or a tornado. Something that is picked up on the ground and it's moving in a direction, but the curl of it is pushing the thing up. It's rotating and going upwards because the curl is a cross product. So we have IJK. I mean, if we do this, this is why you see Quinn doing this, the wrap. It curls the hand. So it's curling around, the vectors are curling around the direction of the curl. And so curl is rotation. If we've got a Z component where everything in this direct, the K hat is 0, we're just looking at how well something rotates around a point. Is flow going around the point in a clockwise direction or counterclockwise?
So if it's going in the other direction, does that mean that the curl is going to be negative?
Yeah, one is positive, one is negative. In a 2D field, where the Z component is 0, curl is always a 3-dimensional thing. But if we look at where the Z component is even, it's like rotation. In fact, they often call it the rot. I want to say this is the curl is, or the rotation is greater than 0 going this way. And this is less than 0. And it follows the way we think of angles. You know, angle when we go counterclockwise, we're increasing in theta. You know, when we go counterclockwise, I'm sorry, when we go clockwise, we're decreasing theta. Counterclockwise, we are increasing theta. And a perfect example, if you want to see this in real life, if you make coffee or tea or something like that, or shit, even fucking Kool-Aid, you got the water in there and you put this shit in and you stir, let go of the spoon, and the spoon keeps going because there's forces in a rotational manner that are propelling the spoon along. That's the idea of curl.
Each particle is its own.
We have a very valid question. What is wrong with Kool-Aid?
Don't,
Nothing's wrong with the Kool-Aid. I love Kool-Aid. Kool-Aid and vodka are awesome. It's the cheap man's get wasted drink. There's your, oh shit, that's on record too. There's another one for you, Ben. Make all the memes you want to, things Jones tells you. Hey, I was a student too, and I'd buy some cheap, like every student. Well, not every. I bet there's some students in here. I know Mr. Blakely wouldn't drink alcohol at a young age like that. But I wasn't a young age. I was in my late 20s when I was in college, and I liked drinking. That's neither here nor there. It was Kool-Aid and vodka for me. That was my drink.
Kool-Aid and cyanide is my favorite.
Because Kool-Aid is cheaper than soda. All right, let's look at the next one.
That's what I got that high score. Let me do it again.
What was the next one? Let me go look at it. We have
I don't know why, but that's the worst first.
Winners don't use drugs unless it's Kool-Aid. In case, do lots of drugs.
I don't recommend you drink while you're going to school, just because I did it doesn't mean it's an intelligent thing to do.
Doesn't it give you like an edge? Does it give you like an edge against all other students though?
Yeah.
Is it like, what is it? I mean, they start with like during school, why they can't like, they can't allow you to train because they're like the advantage.
I think I even showed up to James's father's class intoxicated. Intoxicated, but like still alcohol in my system one morning.
You get the
What is the value?
It's just so much what to do. So the way it's kind of good. Yeah, which is
What is it? What's the stuff that makes you like calm down? Like that's the opposite for me.
So there's the divergence of F. You just do distribute it out. Curl of F.
So behind.
All right, so let me write out my thing along the bottom.
Yes.
Shouldn't the sine squared z be a chain?
Oh, changed. You don't have a sine squared. Oh.
Sorry, I
you
didn't take the
already
derivative right. Look at me, fucking, I've gone too quick. 2 sine z cosine z. There you go.
got it. Go.
Sometimes you're positive and sometimes you're negative.
And sometimes you're neutral. I mean, sometimes you're also zero. Hey, imaginary numbers have feelings too.
What?
No, I didn't. I said positive. I said positive numbers.
Whoa, what is going on?
Positive or negative. I always said I was positive. That doesn't make any sense.
It's only positive.
Oh, what happened
Yeah,
there?
what's your tips for passing this class? That's how it's been shown to get this one. See that, but then. Like, one second.
So whether that's going up or down is dependent on X and Y. It looks like Z doesn't mean shit to any of this. Where you're at in the vector field in terms of height does not affect the curl at that point.
Why does it mean anything? X?
I'm still doing the last pulse. I finally finished it. I'm just doing that. I don't know what to do. I don't know what to do now. You have the numbers.
You have the
Both basically. That's it. I think.
yeah, dot and dots. It's just like steps.
You guys ready for some more?
So that's it. That's the answer. What does that tell me?
It describes
The direction.
a part of the vector field, yeah. My understanding of it is that the curl and the divergence.
Because you drew like a picture where he's like with the.
This is back related to chapter 14. I thought I'd do another way of explaining how to, when you're converting, I always started on the inside working out, but I think it might be a little bit easier going on the outside working in if you're uncomfortable with boundary conditions. So I want to draw a picture. I'm going to do a 2D picture first. This is my equation I'm using. The function doesn't matter. I'm just going to change the boundary stuff. I'm not integrating anything right now. I just want to show how to go about doing it. So like in 2D, the outside one, 0 to 3 along the outside, that should say X. Along the outside one is saying that I am going from, maybe I'll change the black to be orange to represent the field I'm working with. 1, 2, 3, 0 to 3. I'm in this region. So that covered the 0 is less than or equal to X, less than or equal to 3. And now I need to address the 0 is less than or equal, not 0, negative square root of 9 minus X squared is less than or equal to Y, which is less than or equal to 9 minus X squared. So I'm going to use a different color for that. I should have wrote the ink part in a different color. I'll do this in blue.
That's that.
9 minus X squared and negative 9 minus X squared is, if I go down 3 and up 3, this part is a half circle like this, and that part is a half circle like this. And so I'm doing that, the Y component's covering all of this like that. So the part that's overlapping was what we're looking for. The overlap part is just that half circle. So this is the region we're looking at in the XY plane. So if I do that in the Z component, I am looking at something like this in the XY plane. Now, assuming I did that a little bit better.
Well, it's like a bowl.
And now I got to look at the other boundary conditions.
A bowl top and end.
The other boundary condition is negative 9 minus x squared minus y squared is less than z, which is less than 0. This part on the left is x squared plus y squared plus z squared equals 9. So that's a bowl of radius 3, and that's on the bottom half. So if I go down, let me do this curved part in blue. I have it, I'm going down 3. I've got a bowl going downward, and it's connected over there. And I don't have, the upper limit is 0, so I don't do anything above it. So this looks like I have of a sphere. I only have the 1/4 of it. I have a wedge. Like if you cut an orange into fourths. I have the 1/4 that is in the below the z-axis and greater than y equals 0. So what does that mean in spherical? In spherical, my radius is going to 3 on all of those. So both cylindrical and spherical, we've got 0 is less than r less than 3, 0 is less than rho less than 3. On theta, I'm only going from 0 to pi, and that matches up along both. In spherical, spherical starts at the top and rotates downward. So I don't start the wedge until pi over 2. And I finish at pi. The z component in cylindrical is what we already had. Negative 9 minus x squared minus y squared is less than z less than 0. So cylindrical versus spherical. But I think it might be easier if you, like the point of this exercise or to do this was to show starting on the outside and working in, coloring in the regions, and then looking for regions of overlap. So I started in a simple image and then upgraded to 3D when we got to the final component. When I was teaching it, I started on the inside and worked outward. So I started 3D and worked to 1D, so it's not as clear. I think this might be a little bit clearer. Carlos said it worked better for him yesterday.
Top of the z-axis, hold on every time.
Even if it's not part of the case.
Yeah, even if it's not part of it, and then it goes down like that, down the curve, down to the x-axis.
Really. That's how it
This
is.
looks like my picture looks like it.
Choose, and then it goes all the way down to the end of the shape at the bottom of the z-axis.
the pi.
If I were looking straight down, this is Y and this is Z,
Well, same idea that you start.
and X is coming out of the board, we have that. That's what we're looking at.
Yeah. So yeah, exactly.
Starting point.
Yeah, it's just a starting point, starting with the axis.
Okay.
Data starts at.
Right.
So it starts in the x-axis.
All right, next part. That's just a quick recap or another way of looking at how to do the boundary conditions and how to change them. I know that's probably the hardest part on this next test for many of you. So you gotta, drawing pictures helps.
Let's see if we can go.
All right, back to our previously scheduled topic of chapter 15.
Also available as a drawing class.
Let's show that the divergence of the curl of any vector field is 0. But we're gonna just use a specific example. We're not gonna do like the general proof. You can do the general proof if you'd like. I think I do it in the videos, to be honest. So if we're gonna do the divergence of the curl, this is div curl F. We gotta do the curl first. So we're gonna do the divergence. Let's call the curl of FG. So I still need to take the divergence of G if G is. I'm writing out the curl stuff right now. I know a lot of you like the subscript notation for partial derivatives, but they don't have a pretty one for the del operator or novel. You gotta just do the ddx, ddy, ddz. So ddy of negative e to the yz is negative ze to the yz. Yz sounds like wazoo. I like it. Sounds good. Minus ddz of 3x e to the y is 0. Minus j hat. ddx of negative e to the yz is 0. Minus ddz of e to the xz will be x e to the xz. It looks like a C. I want to rewrite it. There we go. And my K component, ddx of 3x e to the y is 3 e to the y. Then we're going to subtract ddy of e to the xz is 0. So G is negative z e to the yz. The negatives cancel on the j. I've got x e to the xz there. On k, I got 3 e to the y. All right, so now that was G and it's a vector. And now I want the divergence of G. Let me change colors for divergence. ddx, ddy, ddz, negative z e to the yz, x e to the xz, 3e to the y. And it looks like this is 0 and 0 and 0, right?
I was wondering why they hadn't said anything yet.
So the net flow through any point is 0. Earlier, so we've seen the divergence equals 0. I think on our previous, we haven't seen where the curl equals 0. If the curl equals 0, this is said to be irrotational because there is nothing swirling around it. But then we didn't, these two are unrelated. This was divergence is 0. So we did the divergence of the curl. This is a true thing. The divergence of the curl of f is always 0.
So saying that's irrotational, I guess that means that it's the vector field's just not moving anything
not twisting.
particular. Not twisting.
No twist. So if it's a river, it's flowing straight.
What does that mean? Second?
So basically that means it's not twisting. So say you have the tornado, if it's the curl is 0, that just means there's no tornado. There's no twist. Because the curl is a measure of how much something spins and how much a vector field will twist.
This might help for you. For curl, I've got a river. I'm going to do 2 rivers. So this is my river, and this is my river up here. When there is a curl on a sailboat, as it's going down, the sailboat starts to curve, twist. So this has got some curl to it. There's some rotation.
I think it's fun.
On a river that doesn't have rotation, where the curl is 0, the boat just flows along and never changes orientation, never spins. I'm assuming it's flowing from like this direction. So there's like little eddies in the water, where there's a little bit like the water is swirling a little bit as it goes along. But here, there's nothing. It's just a straight shoot. The water's not swirling at all. So there's no twist or rotation of anything. I think the boat on a river is a great example. I can't think of a better one right now, but if I do, I'll let you know.
You were saying something about angular curl?
Well, that's have curl rotation. That means they have an angular. Oh,
Yeah.
one that doesn't have.
It probably won't have any angular curl.
Well, that basically equals 0.
That sounds like
river right now, I think.
So curl is our angular velocity. Somehow.
You write it down.
I'd say it's more connected. I'm more, I can't verify.
So
But I
some
think
other functions or some other outcomes we'll see.
It's like IRR.
Oh, no, not the picture. Not the
But we showed the divergence of the curl was 0. We just did this in the last problem. The curl of the curl, maybe we'll take a look at this tomorrow. The curl of the curl is something you're not ever going to remember.
It's just a curl of curl.
It's the curl of curl.
Yeah.
It's almost easier to calculate what the curl of the curl is. This is called the Laplacian.
Wait, what? Wait, what?
Oh, I remember that. You
And-
talked about that with-
Del squared is del dot del. So Laplacian of f
What
is,
the heck?
We're squaring now.
um,
Now let's square.
Let's go.
yeah.
The top product, yeah.
Honestly, who wants to make this one?
Oh, so it's like
more like the
the double
gradient
gradient.
in this case. It's like the gradient. Gradient of the divergence.
Oh, what is it?
It's the gradient of the gradient.
So div curl and curl work. If we look at curl div and div div,
Square. Cubic.
so this is a cross product.
Is that really good?
Both of these operations, the divergence of f is a scalar. So if we try to take the curl of a scalar, it doesn't make sense because curls work on vectors. Same thing with the divergence. The divergence of a scalar doesn't mean anything. It's got no direction. So these two are senseless. They mean nothing.
Just because it has something else.
I don't do my PhD on it.
It's not like.
I don't have my curl. The divergence is important. And then go back to.
I want all the like the parts.
Like, everybody thinks, yeah, that's my one, it's my life. Well, you can't do it without it, gonna be what is our killer.
Oh, Mr. Jones.
Yeah.
When you're finding the curl of the curl, are you doing the cross product twice?
Say that again?
When you do the curl of the curl, are you doing the cross product twice? Or
Yes,
How does that
you do the cross product on f, and then you do the cross product on the outcome of the curl of f. It's like, how much is the twisting? It's fucking confusing to even picture.
Oh, the twisting around, but it's off the twist. It's like a dart. There's also.
So I goes by.
That makes it.
And something else I wanted to show you guys, what's his name? Eric brought this to my attention. We were talking about it at Starbucks yesterday. We were talking about the Jacobians and how one is the inverse of the other if you do it one way. We saw that it worked on two components, but it also, one of the problems in the homework is actually show that it works for three components. So you can do you can do the Jacobian in either format, starting with UVW. You just got to remember one is the inverse of the other, and the one you're looking for is the one on the left. So starting with X and ending with UV, partials with U, V, and W. That's the one you want. So if you're coming to Starbucks tonight, email me or say something on Discord. If no one's coming, I'm not going to go over there. This is the one you want. if you want to use that, you can on the test. I think you're better off sticking with switching to X, Y, and Z first and then doing it. But to each their own. So the one we want is there. This one is effectively 1 over the Jacobian of UVW.
Oh, so you looked up what that Jacobian idea is.
It should be close to.
No, it's the task, the question.
Yeah.
Tell you to improve it.
Oh, okay.
Because that means if that tell you to show it. that
Yeah,
means-
on the problem, they don't ask you to prove it, but they ask you to show that it works on a specific thing.
Okay.
Proving it in general is a lot more work than that. Other than that, I will see you guys tomorrow.
All right, I'll be holding my SI hours from 1 to 3 today. Announcement will be sent out later.
What'd you get?
I know Ben wants to do the Jacobian with the XYZ. I know he does. That was more for you, Ben, than anybody else. You and James, maybe Eric.
Yeah.
I know you want him. See you guys tomorrow.